Hello, my name is Justine Pendergraft, and my project was autonomous drone flight for real-time air quality monitoring. So last year, I had an internship through Portland State University with John Lepore, and this year my project has been a continuation of that internship. So essentially, the project as a whole is using drones to autonomously collect data, and last year it was more focused on the data part. This year it was more focused on the drone part. So what I had in terms of data was I had a Bluetooth air quality sensor called an Atmo tube, and it takes things like air quality, temperature, humidity, stuff like that. And I wrote some code to scrape all of the data that I was transmitting off of Bluetooth, and then use that and pair that with simulated GPS data from the drone. And so essentially what you can do with this drone, the Matrix 100, as it is called, is you can plug it into a simulator, and then use something called robot operating system to sort of just take various pieces of data off of the drone, things like GPS points, XY position, stuff like that. And so I took those paired Atmotube data with GPS data, and then put it on a simulated map of downtown Portland, which was where I was at the time. And so then each of these data points, this is plotting heat, because I had a lamp and I was just moving it further and closer to a lamp. And so this was data points collected as I simulated flying the drone around. And the sort of colors you can see in the background, that's the result of something called a Gaussian process regression, which is kind of like a very simplistic machine learning algorithm, where you can use prior data to generate predictions of the surrounding area. So just kind of like interpolating, extrapolating sort of data. And so these purple areas, you can see that's basically where there's not enough data to figure out. But for the most part, it's got, warmer colors where there are warmer colors, cooler colors where there are cooler colors, and it makes sense. And so this year, what I've been working on is actually mounting the computer physically onto the drone, because, for testing, it's fine to have like a monitor and a keyboard stuck to the computer, which is plugged into the drone, but you can't actually have that if you want to fly the drone around. So what we had, the computer we're using is called a Jetson TX2, and the computer itself, it fits in your hand, but the carrier board is like a foot by a foot. And so it's actually called a developer board. And so I essentially swapped that developer board out for a carrier board called an Orbity, which is much smaller, about the size as the computer itself. But essentially with that came a lot of sort of technical, I guess, time-consuming things that don't really translate well to research. It was just this sort of step took like a lot of troubleshooting. Right, and so in addition to that, I also designed a carrier for the Orbity in order to actually mount it to the drone. So I've got a LiPo battery, as well as the carrier and some jumper cables that go from there into the robot or the drone. Basically, where I'm at now. All I need to do in order to have the drone flying autonomously, because currently I have a program that will have the drone fly around autonomously, collect some data points, and then come back. That works in the simulation, but in order to actually translate that to reality, you gotta tie the beginning of that program to a button push and have it start up when the computer itself turns on, and at that point, pretty much the drone's going to be able to fly around autonomously, do its thing. And yeah, thank you for listening to my presentation.